We have gone into the lower worlds of assembly and built an EVM interpreter in the EVM. It is built entirely in assembly and made to be gas efficient. The interpreter contract is lean and short, and it is compatible with Solidity, Yule, and Taylor contracts. What can you do with an EVM interpreter on-chain? You can run fragments of code or entire smart contracts in the EVM without deployment. So you can manage and maintain contract upgradeability, have a database of runnable contracts on-chain, deploy contracts programmatically through governance, and it is the basis for the next version of Taylor and Luxor. And now the technical demo. This is a Solidity contract that we are deploying with Remix on the JavaScript VM. Notice the sumVar variable, which is 5, and the increase function. We are going to copy the address and go to this smart contract written in Yule, an intermediate language. Set the address here, and this contract will call the sumVar getter function and return the sumVar value. What we are going to do is compile it with our Remix plugin, take the bytecode, go to our EVM interpreter, run the bytecode, get the runtime bytecode, and interpret it. And we get the value 5 from our sumVar variable. Now we can go to this Yule contract, which calls the increase function. We are going to get the bytecode of this contract and go to the EVM interpreter, run the constructor bytecode, get the runtime bytecode, and run this one. And now we'll repeat the actions with the get sumVar bytecode. And the value has changed. It's 5 plus 9, 14. So the EVM interpreter takes the bytecode opcode by opcode and executes it. And I will show you one more example. This is a contract written in assembly with a jump if instruction. So if we have 1 here, jump E will jump to tag 1 and do a 2 plus 4. And we can see the result is 6. If we have a 0 here, jump E will continue the instructions here and will do a 2 multiplied by 4. And we get an 8. Now we can take this bytecode and go to the EVM interpreter, get the runtime bytecode, and we should see an 8. So if we modify from this runtime bytecode, this is a tag and this should be our value. If we put here instead of a 0 a 1, we should get a 6. And we have the 6. So the interpreter can successfully manage a program's control flow. This preview is preferentially released to my Twitter allies. I would love feedback on how this tech can be used and how it should be disseminated to the general public.